Welcome to The Explainer. Today, we are diving deep into a truly fascinating source that pulls a theory of particle physics right from an ancient text. It's an idea that asks us to look at the very building blocks of our universe in a completely new and honestly, a pretty mind-bending way.
So, what is this great mystery we're talking about? According to the source we're digging into today, the biggest puzzle in all of physics can actually be unlocked, but only if we understand what a particle is really doing when it moves and interacts with the world around it.
And the answer, this text proposes, isn't somewhere out there in the cosmos. It's found deep inside the particle itself. It argues that every fundamental particle, a photon of light, an electron, it isn't just a simple single point. No, it has a complex and dynamic internal structure.
Okay, so what is this secret geometry then? Well, the source describes it as a hidden internal structure, one that contains two very distinct centers of power tucked away inside every single particle.
The state of a particle, it turns out, all comes down to the orientation of these internal centers. When a particle is just moving freely, zipping along, they're held apart at a right angle. The source likens this to an open fist. But during an interaction, that all changes. The internal geometry shifts, the centers pivot and draw close together, like a closing fist. And this internal transformation, that is the very mechanism of interaction. The text even gives a specific name to the force that drives this change, Dhananjaya prana. This is described as a kind of vital energy, a force that's responsible for changing that angle between the power centers. It's what enables interaction and keeps the particle itself in perpetual motion. This whole idea of a shifting internal geometry, well, that's the absolute key to understanding how particles actually interact with each other, at least according to this model. The process is laid out for us in a really clear four-step sequence. It all starts with the particle in its free state, right, with its power centers apart. Then, as it approaches another particle, that internal force, the Dhananjaya prana, kicks in and starts working on those power centers. And finally, the geometry shifts, the centers draw close, and bam! The particles unite. Now, building on top of this mechanical model, the theory proposes a really fundamental rule for these interactions. And this is where it gets super interesting, because it argues this rule has a fascinating parallel in modern physics. The rule is simple, but it's also incredibly profound. A particle can only engage in an interaction with one other particle at any single instant. The source calls this the principle of singular interaction. So basically, once a particle is engaged, it's busy. No other particle can join that specific dance at that exact moment.
And what's so cool is how the source connects this ancient idea to things we know today. It actually quotes a standard physics textbook, pointing out that the one-to-one energy transfer between a single photon and a single electron is a recognized phenomenon. It's presented like a modern echo of this ancient rule.
The text even applies this rule to very specific scenarios. For instance, when one photon hits an electron, a second photon can't interfere at the exact same instant. It literally has to wait its turn. This, the text argues, is why interactions in the quantum world happen sequentially, one after the other, not as some massive, chaotic pile-on. So to make this abstract idea of interaction a little more real, a little more tangible, the source introduces a powerful and honestly a really beautiful analogy.
It suggests that when a particle combines with another one, it goes through this pretty radical transformation, one that is strikingly similar to a fetus being born.
And the comparison is pretty striking. Just like a fetus at birth sheds the placenta, which is called geryu in the text, to enter the world, an interacting particle is said to shed its outer luminous aura of energy and force in order to combine with something else.
Now here's the crucial point. This idea offers an explanation for a common question in physics. Where does a photon's incredible speed and light go when it's absorbed by an electron? It seems to just vanish. But according to this theory, that energy isn't lost at all. It's simply absorbed and integrated as the particle sheds its free state aura to enter a new combined state. But hold on, that raises a pretty big question. If a particle sheds its outer self, does it lose its fundamental identity? Well, the source says no. And this is where it introduces one final, really critical concept.
The theory's solution is that particles have not one, but two different coverings. There's the geryu, that's the outer luminous aura we just talked about, the one that's shed during an interaction.
But underneath that lies a second, inner covering called ulb or vasa, and this one is permanent. It's never lost.
This inner covering, this ulb or vasa, is described as the particle's indestructible core essence. It's a subtle layer that preserves the particle's fundamental identity and characteristics no matter what interactions it goes through.
And why does this matter? Well, this permanent inner layer is what allows a particle to maintain its identity over time. It's the reason an electron, for example, can absorb a photon and then later re-emit one, returning to its previous state with all its original properties perfectly intact. The core was always there.
So what we're left with is this fascinating blend of ancient philosophy and modern physics. And it leaves us with this final, really provocative thought. Are these concepts just powerful metaphors to help us visualize the bizarre quantum world? Or could they be describing a forgotten science, a genuine glimpse into the hidden dynamic life of particles? It's a compelling question to think about.